Hello, welcome to this first session on the Learning R course. My name is Ed Ryan and I'm a postdoctoral researcher working in collaboration with the University of Manchester and Arrow Global. This R course will consist of 6 sessions which are listed here. There are many more topics I could have included in this course, but these are the topics that I think will benefit most people. I'll be explaining these topics at a base level, so this course is ideal for those who are new to R and indeed new to coding in general. For those who are more confident at coding, I'm hoping that many aspects of this course will also be useful to you as well. This session is an introduction to R, and in this session I've included all the aspects of R that I think you need to know in order to be able to use R effectively. So why use R? Well, there are a number of reasons, and a few are listed here. First of all, it's free to download and use as a result of being open source. It's simple to use, especially compared to other programming languages. And in that sense, it's probably the best language to start with if you're new to coding. There are also a lot of people who use R, and as a result, the amount of resources online is a huge amount. Therefore, when you do come into problems or you need help with something, there's usually something online that can help you. These are the topics which I'll be covering in this session. I'll first show you how to install R, how to use R as a calculator, using a script file, importing and exporting data, the different data types such as numerical data and characters, the different data structures such as matrices, data frames, vectors and lists, and how to convert between them, subsetting missing values, and finally how to get help with other problems. To install R, if you haven't already done so, you need to go to the web link at the top of the page. I recommend you also install another program called RStudio, which provides a useful interface to R. You can run R without RStudio, but the interface used by R is quite basic and simple. RStudio has a more professional look to it, has features that help with our experience. To install RStudio, you need to press the link at the bottom. I should also say that if you do install RStudio, you need to make sure you install R first. You can go to Google or another search engine and find these links by searching R download and RStudio download, and these should take you to the correct websites. I would just be aware that you can download R and RStudio from third-party websites, but I can't verify the quality of those third-party websites. So using R as a calculator, and I should actually, before I start this slide, if you haven't installed R and RStudio, I recommend you do this now and pause the video and restart it when you are ready. So assuming that you have installed R and RStudio, the first thing we're going to do is open it up. So you would open it in the usual way as you would with another program. So you just click on RStudio. I have it saved as a shortcut here. I'm just going to close and just going to get rid of some of the stuff in here. So this is the what the RStudio interface looks like. You've got the console where you type commands or commands appear and they're executed. Top right, you've got the environment, which is where variables that you've created are displayed. Got the history of commands. This is where commands that you've executed are stored as well, which can be quite useful. And then down here, the bottom right, you've got different things. So you've got help, you've got packages, you've got plots, which might be where a preview of a graphical plot that you've created would be shown. So we're going to start off by copying the thing that was in the slide. So 6 minus 9 plus 10 times pi power 3. I should say that the star is the symbol for multiplication and the hat sign is the symbol for the power of. We press enter and we get an answer. And we're next going to do a command which is the same as before, but we're going to remove the brackets. Now you could type out the commands, but I've just pressed the up button on my on my keyboard, and that reveals the previous command. So I just can do that and then delete the brackets. That's a quick way of doing that. I press enter and I get a different answer. The reason why they're different is because of the order of mathematical operations, BIDMAS. And the point of all this is that I want to demonstrate that you can type these numbers into a calculator and you get the same answers as you do here. So that's important because R can do very basic things like when you do in a calculator, but then it can do a lot more as well. The next thing is the exponent of log 5. Now, log is the natural log, base e, and the exponent of is the inverse of the natural logarithm, so we should get 5 as the answer. Now the final thing is log 1000, comma 10. Now the comma 10, the default for the log function is, in terms of the base, is e, so it's a natural log, but you can specify a different base. So here I've specified base 10, and I'm asking R to calculate log of 1000. That's 3 because 10 to the power of 3 is equal to 1000. That's how we define a logarithm. So this is all great, but quite often when we're writing code, we are writing lots of it. We want to be able to store that code. So the way we do that is use a script file. So we go to new file and then R script. And what I'm going to do is I'm going to copy these 4 commands that I've just done. And I'm just going to delete the things that I don't need. Okay, we're going to save this. And we're going to call it R course session 1. So I've saved it in this directory here, R course session 1. And what I can do is I can run it by highlighting a particular line and pressing the run button. So this has the same effect as typing it out into the console and pressing enter. I can also highlight more than one line, so I can highlight all 4 lines and then press run, and that's run all 4 lines one after another, but I've only had to press run once, not 4 times. Instead of pressing the run button, a shortcut on your keyboard is to hold down the control button and then press enter. So that's the same effect as pressing run. You can do this with 4 lines, 1 line, or 2 lines. So highlight. The key thing is to make sure you highlight the lines that you want to execute. So I just want to execute these 2 lines. I'm going to then press control, hold down control, and then enter. It's executed those 2 lines. The final point is comments. If you want to write a comment, you start the line with the hash symbol, or it's called a pound symbol if you're American, and we would call it something that to describe what we're doing. So this would be slide 7 or 8 of session 1. Comments are really important because they help to describe the code that you've written. This is important for yourself, particularly if you're looking at some code that you created maybe a few weeks ago and you can't quite remember what you were doing. The comments can help remind you. Also, if you're sharing code with someone else, that other person can make sense of your code with the comments that you've written. To import and export data, there are a number of different ways of doing this. The first thing you need to do is you need to set your working directory. So we use this function here, set WD, which stands for set working directory. And this will vary according to your machine and the directory in which you're saving your work. And this is actually the directory where you're going to be, the data file that you're going to store is going to be imported, and also where files can be exported. It's usually where your R script is stored as well, but it doesn't have to be. Your R script can be stored somewhere else. So the number of different functions that read in data. A common one is read.table. This is useful because it can read in lots of different types of data which are in table format. So you would put in the file name here. The header refers to whether you want the column names to be read in as well, and then sep is represents how the data is separated by a comma or a space or whatever it is. If your data is a CSV file, then read.csv is a good function to use, and it has the same arguments except doesn't have the sep argument. If you're exporting data, then it's a similar kind of function, but instead of read, we put write. So I'm just going to go through an example next. And I should say just before I continue, there are a number of other functions that you can use apart from these two. These aren't the only two. These two are the ones that I use a lot, but there are many other types that you could use to read in these kind of files. So I'm going to do an example, and you can also, as I write the R code, you can also be writing it as well and seeing the data as well. So if you want to do this, you need to write down this web address. So this is a website for an online data repository called Zenodo, and this particular link will take you to the dataset I want to download. The data file contains a model output of gross primary production, which represents the amount of carbon taken up by plants via photosynthesis. This model output was from previous research I did in a position in the US. So the file contains 4 columns of gross primary production data from 4 treatments. So the model output is from running a model which has been calibrated from field data. And what we're growing grass under different treatments. So we had a control treatment where nothing external was happening to the grass apart from just growing. And then we had a treatment where a heater was put on the plots to simulate warming. We had some plots where elevated CO2 was pumped into the plot via piping. We had a treatment that included both warming and elevated CO2. So once you've downloaded the data, save it to a relevant folder on your computer. And I'm just going to show you how to do it now. So I'm going to, in fact, open another R script. This is code that I prepared earlier. And so we did set the working directory. And so again, just to emphasize, this would be different probably to be different for you, depending upon where you stored your data. But this is where it's stored on my machine. I should actually say, the actual data itself. So it's called FACE, photosynthesis data. The FACE stands for prairie heating and CO2 enrichment. And if you're interested in the experiment, learning more about it, if you type in FACE with a PH and then experiment into Google, the first result should take you to the website for the experiment. And within that, there's a list of papers that were published. In that list, you'll see a paper on gross primary production, and that's one of the papers I produced from my time in that position. So we're going to read in the CSV file. And this function names is quite useful because it gives the column variable names of the data set, and also head, this gives the first few rows of the data set. So if we run all of that, I'm going to Control Enter. So you can see it's read it in. And you can also actually open the actual file itself. And you can actually compare these first few lines to satisfy yourself that it's the same thing. Okay. Quite often, data stored in SQL, data stored in a database such as SQL Server, you can read data in directly from the database as long as RStudio and the database are stored on the same server. So to do that, this R code will work. I've used this R code a lot in my current job, and the things that are in blue would be specific to your particular database itself. So the server name, which would have maybe many databases, the particular database name, which would have the table where your data stored, and then you have the SQL syntax here. So I've just put 2 lines. This could be any number of lines that you would, whatever SQL syntax you would use in order to extract that table or part of that table that you want to read into R, you would put in this space here. So I'm not going to give an example here, but I can tell you that this definitely works. You can also import data and also export data in a quite simple way through a file type called rdata. And I'll just demonstrate this for you next. So we're just gonna clear the environment. Okay. So let's suppose you've got 3 variables A, B, C. We're going to, and we've set them to be 1, 2, and 3. I'm going to set the working directory. Now I can use this function save to save either all the variables, or I'm just saving A and B here. But before I actually run this, I just want to show one aspect of R and RStudio that's quite useful. So whenever you close R, it gives you the option to save the workspace image. If you press save, what you'll find is that there's this file here which hasn't got a name, but it has this, but you can tell by this kind of image here. This file contains the all of the variables and the data structures that you've created in the previous R session. This file here contains all the history of the commands, which can be useful. So if we reload R, and what you'll find is that okay, so normally, and as it happens, it hasn't worked, so I'm showing it. Normally these would load automatically, but I've just opened, I've used this symbol here, to, and then I've opened the actual, I've read in the data file from here directly. So I don't know why that's happened, but anyway, that's fine. So I wanted to show you that because that is quite a useful feature. But let's say you just want to read in, you want to save certain particular variables, you don't want to save the entire thing. So this would be useful because what I've just demonstrated just saves your previous R session. But you might have data from a week ago or a few weeks ago that you saved. So we're going to do the same thing now. I'm just going to get rid of these two files. So I'm going to do the same thing, and now I'm going to save it. I'm just going to save A and B, not A, B, and C. So I've created A, B, and C, but I'm only saving A and B. And you'll see that there's now this file called stuff.rdata. This is what I called it, stuff.rdata. And I'm going to remove all the objects from the environment. I'm going to close I don't want to save. I'm going to get rid of that history file as well. And now I'm going to open R again. So now if I do set working directory and load stuff, I should just get A and B. So rather than A, B, and C, I've just got A and B. And I should just say something I did mention earlier, but I just want to say again, this R script that I'm using is in a subfolder of where my data is stored. This is my working directory, but my R script is in a subfolder of that working directory. But that's okay because, like I said before, it doesn't matter if that's the case. Normally, we would put our script in the same folder as the working directory. But I just wanted to, I didn't want to confuse you. This is this R script that I created earlier in the session, and I didn't want to confuse it with what I had created beforehand. Okay. Assigning values to variable. Now this might seem kind of obvious, but I do want to go over this, particularly if you are new to R, because it's quite important. So if you create a variable, say A, and you assign it a certain value, it could be 8, the number 8. The most obvious way to do that is A equals 8, and this works and it's perfectly fine. But R also accepts another way of assigning values. This technically we use the equal sign is we are kind of assigning it, but the 8 has to be on the left and 8 has to be on the right. This syntax here with a dash and a it's like an arrow. This means, strictly does mean assign. It says 8 is assigned to A. And the good thing about this syntax is that you can actually put 8 first, unlike the equal sign, as long as the arrow is pointing towards the letter or the variable name. But just be aware that if you do that, you must make sure the arrow is the right way around. So this wouldn't, on the right hand side, this wouldn't work because A can't be assigned to A. You'll get an error message. Now most of the time, if not all the time, I use the equal sign, but I just wanted to make you aware of this other syntax for assigning values because some other R users do use this in their coding. So I just wanted to make sure that you were clear about what it means. Data type. So there's 3 main data types: logical, numerical, and character values. Logical we wouldn't really use to assign something in the same way with numerical and characters. It's more usually it's something if it's true or false. So for example, in this example, you've got x is equal to 5, y is equal to 3. If you do x is greater than y, R will give you back true because it's true. If you did x is less than y, it would give you back false because the answer to that is false. This is logical, is used quite a lot in things like subsetting, which I'll talk about later, and other aspects of R. So it kind of crops up in different places. But when you're actually assigning a letter or a name to when you're assigning a number or a character to something, like then, like say A is 5, B is square root, then the thing you're assigning that's being assigned can either be numerical or a character. So here we've got A is 5 and B is square root 2. And I should just say, actually, the semicolon is a way of putting two different commands on the same line. I've got it here as well. I could put these two lines, the commands in these two lines, as 4 separate lines for 4 commands. But if your command doesn't take up a lot of space in the line, it can be a good way to reduce the number of lines you have in your code. So by just doing A and B, this prints it out on the screen what those values are. Characters, they are non-numerical data types. So here, although this is a number 1, I've put speech marks around it, and the speech marks around it indicates that it's a character. It tells R this is a character, not a number. So it has no numerical value. If I did A plus 3, it wouldn't know what to do. But B is equal to 1. This tells R that this is a number, and it's the number 1. So if I print out on the screen A and B, I get 1 and 1, where the first 1 is a character. If I assign A to B hello in speech marks, this is another list of characters. And I print it on the screen, it just becomes hello. Now let's say I have another variable called C, and I say C is equal to A, then C is also hello. So this can be useful if saving you having to type out C is equal to hello. Matrices and data frames. So matrix and a data frame are different ways of storing lots of data, where the data is stored in a table format. A matrix stores generally just numerical types of data, whereas data frames can store numerical data and characters. Most of the time, the data will be in the form of a data frame, but you need to convert it to a matrix to do certain things, such as matrix algebra or creating a column map, and there are other examples as well. This is probably one of the main headaches that people who use R have. They are complaining that the data structure you're using is in the wrong format. And the next slide, or the slide after, in fact, I'll show you there's some commands that you can use to convert between the matrix and a data frame. The other main difference between the two types is that a data frame, we have column names, but then in a matrix we don't have this. So just to give you an example here, if you wanted to create a matrix, you use this command matrix, and then we're creating a matrix of the numbers 1 to 6. N row represents the number of rows, it's 2 rows. N column is number of columns, it's 3. And by row is T for true, means that the numbers 1 to 6 are going to be entered by the row. If by row was equal to F, false, then it'll be 1, 2, 3, 4, 5, 6. N row and N column must be correct. So the numbers, they must, you can't have, for example, N row is 3 and N column is 3 if you've only got 6 numbers. I will complain about that. The function T is to transpose the matrix. That means to swap around the rows and columns. And dim is the dimension of the matrix. So that just means the number of rows, which is 2, and the number of columns, which is 3. A data frame you can create using something like this. So let's create a list, call it L3. C is the command which stands for combine. So we're going to combine the letters A, B, and C to make a list. And we're going to create a new variable or a new list called L3 rep. And this rep function means to repeat the list, which we called L3 2 times. So our L3 rep list consists of 6 elements, ABC, ABC. And then finally, we create a data frame using this function data.frame, where you've got 3 columns. The first is X, where all the values are 1. The second is Y, which consists of the numbers 1 to 6. And the third column has a name called lets, short for letters, and it's equal to this L3 rep list, ABC, ABC. And so notice here, unlike the matrices previously, which didn't have column names, they just indicated what column it was and what row it was. These do have column names. So vectors and lists, they're similar in terms of comparing the two, as we compare also between matrices and data frames. So a vector, strictly speaking, is a one-dimensional matrix. Could be a 1-column matrix or a 1-row matrix. And so, like vectors, like matrices, vectors can only take numerical values, and like data frames, lists can take numerical and character values. So, as I said before, the function C means to combine. So let's create a list. Let's call it X of these 3 numbers: 3.1, 6.7, 7.5. I take the natural log of X, that will calculate the natural log of each of the elements of X. Clearly, to do this, X, all these values must be numbers. If they're non-numerical, then you'll get an error or it won't give an answer for that element. You don't need to use the C function if your numbers are in consecutive order. So in here, we've got a list going from 1 to 4, 1, 2, 3, 4. I generally always use the function C just by habit. You can also create a list by this function here, which is short for sequence. So this is creating a sequence from 1 to 1.75 in increments of 0.25. So it's a list of numbers 1, 1.25, 1.5, and 1.75. And if we do A plus B, what that means is we add the first element of A with the first element of B, the second element of A with the second element of B, and you end up with this answer here. Length of A simply calculates the number of elements in that particular list. So length A's got 4 elements, so it's got length 4. So converting matrices, vectors, and data frames, and I should actually say also lists as well. As.matrix, so we generally convert between a matrix and a data frame. So if you've got a data frame you want to convert to matrix, then use this function here, as.matrix. If you've got a data frame, if you've got a matrix and you want to convert to a data frame, you would use this as.data.frame. You've got a list and you want to convert it to a vector, you'd use as.vector. And this fourth one, as.list, if you've got a vector you want to convert to a list, then use that. So I don't think I've ever really used as.list, maybe a couple of times, but I use the top 3 quite a lot, especially the top 2 I use a lot. As.factor, we only use that in doing regression. Well, that's the only time I use it. Maybe others use it for other situations. Subsetting is a really important part of our so imagine if you're reading in some data and you want to just look at a portion of that data, do something with that data, and then export it to a file somewhere, or you might want to plot a graph of that subsetted data. So you need to know how to extract a portion of the data that you've imported. So in a very basic example, let's create a list. Let's call it X, which consists of 6 letters, A, B, C, D, E, B. Now the square brackets here tells R to select the second element of list of this list given by X. So the second element is B. That's why it gives B as the answer. Now 3 to 5, this says select the third, fourth, and fifth elements of the list X. So the third, fourth, fifth is C, D, E, C, D, E. That's what it will give. And then down here we've got another list Y. We've defined it as being a list going from 2 to 7. 2, 3, 4, 5, 6, 7. Now this has the same length as X. So what this command here says is, with the double equal sign, find me the values of Y in the positions where X is equal to B. So where you've got B in the positions of the list X. So B is in the positions 2nd and the 6th positions. So therefore the 2nd and 6th positions of Y are 3 and 7. So that's why you get 3 and 7 as the answer. Missing values. R is designed to handle missing values. If you use another programming language like say MATLAB, it's a bit of a headache missing values. People tend to use -999 in MATLAB, but in R it was designed from the beginning to handle missing values. So this NA tells R that it's a missing value. It could be a missing value that's a number or a missing value that's a character. It doesn't matter. But importantly, NA is not a character, although it is 2 letters side by side. Those 2 letters like that tell R that it's a missing value. So you can still do mathematical operations in a list which has missing values. We've got a list X. We do X plus 5. We add 5 to the 3 and the 7, but the NA doesn't change. Now this is.NA function I find really useful when you've got a data set you've imported and some of the entries are have got NAs are missing values, but you're only interested in using the values that have no NAs. So this would be a way of doing that. So this function is.NA, it finds the values or the elements in the list, in this case X, that are NAs. So if I was to do is.NAX is equal to true, this would give me just NA because it's the only NA that's in there. But by doing false, it's saying we're not interested in the elements of X that are NAs. We want the ones that are not NAs. So it just gives me 3 and 7. So all the things I've just mentioned in the last number of slides, I'm just going to put it all together in an example that I hope will be useful. I'm just going to so this example just consists of 2 slides. So I'm just going to go through it, but also I'm going to talk through it here, but also I'm going to go through it in R as well, in our R Studio. So the first 4 lines of what we've already talked about earlier on, we would set the working directory, we would read in the data. In this case, it's called this. And we use these 2 functions for the names, the column names, and the first few lines as a check. Now, I mentioned before this function dim, it calculates the dimension of the data frame. Now, the dimension gives the number of rows and the number of columns. So it's a list of 2 elements. By doing a square bracket, then 1, this tells R to select only the first element of those 2 numbers. So this actually tells you R to calculate to list the first to the number of rows the data frame. And we're going to create an index, which is we're going to create a list which we're going to call index, and it's going to go from 1 to n. So n is the number of rows. Now, the purpose of what this example is to read in the data. Index is really the list of row numbers, and within the CS file itself, this is model output, real model output, but I've manually inserted some 5 rows where there are NAs in this third column. And what I want to do in this example is to just subset the first 3 columns. So we're just going to select the first 3 columns, and then we're only going to select those rows that don't have NAs in that third column. So effectively, what we want is a data frame with 5 fewer rows and only the first 3 columns, and then we're going to export that to a CSV file. So that's the goal of this example, and the rest of it is listed here. But I'm just going to go through this first bit right now. So I'm just going to run all of this. And you can check, so if we do n, this gives 1,470, and we can check that as well. 1,400, remember the first row contains the column variable names. So all the data is contained within 1,470 rows. The index gives the list of row numbers, which we can print to the screen, but only prints the first 1,000. But that's fine. Okay, so that's all fine. We're happy with that. And so the next thing, we want to select the control column. So we do that by this command here. So my.data is the name of the data frame that I've imported. The $sign tells R to select the column which has a column name called of control. So R, it's saying select this column, which we identify by its column name called control. And we're going to call that control, just although it doesn't matter if it's the same name as the column name, it doesn't confuse R like that at all. Next, we're going to select the row numbers where there are NAs in the control column. So you can do this similar to that simple example of the is.na, a slide I had earlier. We're going to put true here. So we're saying in my list of row numbers called index, what row numbers are where there are NAs. So I'm going to run that and show you how that works. And that with the control, if you wanted to, you can actually do head of control to see the first few values to satisfy yourself. You could do length of control if you wanted to be absolutely sure. So these would give the first 6 values of the control column. I'm going to run the index.na. So this gives these 5 row numbers. So if you look, you scroll all the way down, you can see that. Now remember that the data has been shifted down by 1 because you've got the column variable names in the first row. So of the data, this is the 1,449th row, and the one after it, you've got a gap of 2, and then you've got 3 more here. So these are correct. They correspond to the row numbers where the NAs are contained. But if we want to now what we want is we want to select the rows that don't have NAs. So it's the same command as before, but we do false here. And we're going to call that index.no NA. Let's do that. And we're also going to compare the length of index, that's the original, all of the row numbers, with the length of the index no NA. And you can see it's 5 less for the, again, that makes sense because there are 5 rows that have NAs, so there must be 5 fewer rows that don't have NAs. Okay. And finally, this is maybe the most important thing. We get of my data. Now remember, this is a data frame, so it has rows and it's a table that has rows and it has columns. And the comma here separates what rows you want to select and what columns you want to select. So this index.no NA is a list of numbers which indicates the row numbers where there are no NAs in the control column. So it's 1,465 numbers, and you've got 1 to 3. So the first 3 columns we're going to select as well. And then finally we write that file. We're going to call it the same as before, but we're going to add a control and no NA at the end to indicate how different this file is. Now, if we go to our working directory, you can see there's now a new CSV file we've created. And I'm just going to put them side by side so you can see. So this is our original one, and this is our new one. So you can see it's only the first 3 columns are present here. They're the same 3 columns, with the difference that this new one now has 5. You've compared the number of rows. It has 5 fewer rows, and it's now missing the rows that have NAs in this 3rd column, in the control column. If you were to compare this one, it jumps straight to 1.54, which is the one up here. So it's missed out the NA rows. And if you were, you could check yourself that it's definitely given the right rows. So finally, getting help. I've gone over some of the basics, but there will undoubtedly be other things you'll come across that you'll need to look up. And one of the best and first places I suggest you go to is a search engine like Google. And often we want to do something, but we don't know how to do it. It could be a specific function you need to use, or it could be maybe a few lines. And the beauty about R in our studio is that someone somewhere has tried to do has already done what you're trying to do. So you can type in something that's reasonably descriptive for what you want to do, and you'll be able to find an example, and then you can hopefully use that example in your own particular code. You can also get help if you know the name of a particular function. You can actually get help about that particular function or that command using the question mark. So this is the function apply. What we do is if we wanted to, we had a data frame, we wanted to say do a column sum or a row sum, we would use the apply function to do that. So I'll just show you what I mean by that. So I've been doing question mark apply. And you can see on the right hand side at the bottom now gives you this. So I use apply from time to time, but when I do use it, I sometimes forget the order of the arguments. So X is the actual data frame or the matrix you're referring to. Margin would be 1 or 2 if it's a two-dimensional array. So one would be the row. I think there will be like a row sum, I believe, and then 2 would be a column sum. It actually says here, yeah, one indicates rows, 2 indicates columns. Function, a fun is short function, so it could be, if it's a row sum or column sum, then you'd put sum here. If it's the mean, a row mean or column mean, you put mean, or it could be min or max, whatever kind of mathematical operation you want to do. And then at the bottom, the examples at the bottom often are quite useful as well. So I sometimes, again, like with the maybe resource I might find online, I might copy and paste this into a new R script and just run it and try to understand what the code means, and particularly how the function is used. You can also find functions related to a keyword. I don't really use these last 2 that much, but they are available to use if you find them useful. So thank you for taking the time to listen to this session, and I really hope you can make session 2. Okay, bye for now.